Hi, I'm Ron Jacobs, and I'm a product manager here at Microsoft in the Patterns and Practices team. And I'm delighted that you've joined me today for this MSDN TV segment about improving application performance and scalability. This is just the latest in a long line of productions that we've put together for you so that you can download these resources, and these really help you to reduce time, reduce risk, and reduce cost. And we hope that you'll take the time to go to our website at microsoft.com/practices and see what we're offering, because we make these all available to you for free. Our goal here is to really help you to build, design, architect, and deploy architecturally sound and secure solutions. So today I have with me Ashish, who's going to assist me as we look at this new guide that we're publishing called Improving .NET Application Performance and Scalability. Okay, so I'm here with Ashish, and Ashish, tell us a little bit about yourself.
Hi, this is Ashish. I have been working for Infosys Technologies Limited, and I have been actively participating in developing the perf and scale guidance here at Microsoft.
So how long have you been working on this guide?
Close to like 9-10 months.
Yeah, and actually I think it was about this time last year that we got the go-ahead to create this guidance about improving performance and scalability. And a lot of people have asked us, why was this the big issue that you decided to take on? So why did you want to get involved in this guide?
Yeah, because we wanted to get out with the authoritative guidance on .NET technologies, and there were a lot of questions which are spread on the user discussion groups, and the customers were asking a lot of performance-related problems, and people were not able to bake perf and scale within their application lifecycle. So this guidance helps in answering all that perf and scale related problems, and helping people to engineer for performance by baking perf and scale within their lifecycle.
And that's really the key thing, right? Because we're trying to get performance and scalability really built into the way that people think about building application. I think it was important what you said, that when it comes to guidance about performance and scalability, you find a little bit here, a little bit there. Somebody writes about some cool thing in their blog, and somebody answers an email. But there really wasn't one place you could go to where all of this stuff was pulled together, but that's what we've done here, isn't it?
Yeah, a lot of product teams have been actively involved in writing this guidance, and the guidance has been blessed with their recommendations and best practices. So you can trust this guidance for best practices for design considerations, technology agnostic principles, and best practices for complete spectrum for ASP.NET, web services, interop, CLR,
yeah.
like that.
So who is this guide really written for?
Well, it's for everybody and anybody who cares for application performance.
And so it's not just low-level tips that some developers are going to be really interested into, but you've really addressed architects as well with this, right?
Oh, sure. The target audience comprises of architects, developers, dev leads, testers, performance analysts. There is something for everybody.
Yeah, and so really, this guidance is designed to really fill out the whole life cycle of the application. And in fact, one of the most important things, in my view, as I read this material, I think one of the most important things is not so much, yeah, the tips are great. Everybody loves little tips, but I think it's some of the things about the process of performance modeling and getting people to really set good, clear goals and to know how to measure them. And we're going to be taking a look actually at a diagram here in just a moment from the book. We'll actually show some chapters on our computer here so that people can see the overall structure of the guide. So let's take a moment and look at that on the computer.
Sure.
Let's quickly go through the overview of the guide. The guide is made of 5 parts, which include the chapters, and then there are the how-tos, and then there are the checklists. Part 1 of the guide, Introduction to Engineering for Performance, it talks about how to apply performance considerations throughout your application lifecycle. Then there is Designing for Performance, which is geared towards architects, and it constitutes of technology agnostic principles and arch and design review and performance modeling. Architecture and design review helps you review your architecture and design. Performance modeling helps you assess your design choices before committing to a solution. Part 3, Application performance and scalability is geared towards developers and dev leads. It contains best practices and performance tips to complete spectrum of .NET technologies like ASP.NET, Enterprise Services, Interop, Web Services, and so on. Part 4, Database Server Performance and Scalability. It helps you improve SQL Server performance. Then measuring, testing, and tuning is more geared towards testers and performance analysts. This helps you monitor your specific performance aspects and to evaluate whether you are going to the right direction and meeting your performance objectives. Then there are the checklists which help you do reviews in your architecture, your requirements, your coding, and basically it helps you review your path, your directions. Then there are the how-tos which talks about it provides you solutions about how to go about solving major performance problems. For example, how to page records in .NET applications. It talks about various ways and various approaches of how to page records, large amount of records. And another how to submit and poll for long-running tasks. It talks about how to go about how to approach the long-running tasks, for example, without starving the thread pool on the server. And that's pretty much it. Let's talk about how the guidance fits into the various application lifecycle stages. The part 1 and part 2 of the guidance, performance modeling, design guidelines, architecture and design review, they are more appropriate for requirement analysis in the design phase of the application lifecycle. And the part 3, application performance and scalability, database server performance and scalability, they are more appropriate for design development phase of the application lifecycle. Then the part 5 of the guide, measuring, testing, and tuning, they are appropriate for, throughout the application lifecycle because you measure whenever you design, you measure whenever you're doing any development, whenever you are doing any testing, because you should be measuring always to check whether you're on the right track. That's it. Let me show you how the chapters in the guide are arranged. Each chapter starts with a quick overview and small intro about the architecture of the technology it is talking about, then the top perf and scale issues which are affecting the technology, and then the important design considerations which you should follow for meeting your performance goals, then the implementation tips, for example, the class design considerations for CLR, garbage collection tips, and dispose patterns, and so on. Let's discuss the dispose pattern, which helps the garbage collector perform an efficient and fast memory cleanup. Now, the dispose pattern comprises of two important parts. One is the finalize method and the other one is the dispose method. You can register for the finalization by overriding the object.finalize method. The actual syntax for implementing the finalize method is in C# and in managed C++ extension is like the C++ destructor as shown here. Now, the finalization process requires a minimum of 2 collection cycles to fully release the object's memory. During the first collection pass, the object is marked for finalization, and finalization runs on a specialized thread that is independent from the garbage collector. After the finalization occurs, the garbage collector can reclaim the object's memory. Now, this process is a non-deterministic process because you can't control when the finalize method gets called by the garbage collector. And in the meantime, the resources are held up and you're not able to use those resources. Now this might be a problem under server load scenarios. The second part comprises of is the dispose method. For the deterministic cleanup, you need to implement the dispose method. You can avoid finalization by implementing the iDisposable interface and by allowing your class consumers to call this dispose method. As I discussed earlier that you need to avoid the finalization process, the non-deterministic finalization process, by deterministically cleaning up the resources. This is very important for unmanaged resources such as bitmaps, database connections, file handles, etc. In these cases, the classic style of explicitly releasing the resources helps us. With this approach, you release unmanaged resources in the iDisposable.dispose method. Now, this method can be explicitly called by your class consumers or by implicitly by using the C# using statement. You can also have a close method if the semantics demand so. A close method better represents a logical operation that should be performed. Now, this might seem logical for things like database connections, file handles, etc. Let's quickly see what the dispose pattern actually comprises of. As a first step, you create a class that derives from iDisposable as shown in the code below. The class implements the iDisposable interface. As a second step, you add a private member variable to track whether the method is getting called, the dispose method is getting called, or it is actually the finalization which is taking place. Now, it is very important to remember that finalization should be only treated as your backup, and your client should be calling dispose for most of the times. Now, you add a Boolean variable to track if the dispose has been called. As a third step, implement a protected virtual void override of the dispose method that accepts a single bool parameter. Now, this is the actual method which contains the cleanup code. This is the actual method which gets called from the public dispose method as well as the finalization code. This is the protected virtual dispose method, and this is the finalizer. Now, assuming that the client is calling the public void dispose method, this is how it goes. We call the protected virtual override method dispose by passing the Boolean value true, and the cleanup code is performed. It knows that this is getting called from the public dispose method, and it releases all the managed state here. In the finalized time code, which is also called when the dispose is called, you released all the unmanaged state of the object. Now, let's assume that the client forgot to call the one last thing is that gc.surprise finalize should be called to avoid the expensive finalization process in your public dispose method. Now, getting back to the finalizer, assuming that the client has forgotten to call the dispose method and the garbage collection has to do the expensive finalization process. Now, this is how it goes. The finalizer calls the dispose by passing false as a Boolean value. Now, it is only this code which gets called. This is the place where you're releasing all the unmanaged state of your object. Now, there are certain other important considerations when you're using a dispose pattern. Let's say you are referencing any static variables in the finalized cleanup code. You should always check for the environment hash shutdown property before checking for the static variables, because this is the property which is used to determine whether the CLR is shutting down or the application domain is unloading. If that is the case, you cannot reliably access any object that has a finalization method. There are certain other important tips also whenever you are using the dispose pattern. Do not implement finalize unless it is required. That is the only time when you are handling unmanaged resources across client calls. Now, whenever you are implementing the finalization, you should implement the finalization to the leaves of the object rows. Let us assume that you have an object which is referencing other objects. Now, the object which is only referencing the unmanaged object should be implementing the finalize method. In this way, it is only that object which goes through the expensive finalization process. Keep in mind that whenever you implement finalize, you should always use the dispose pattern that is implemented using the iDisposable interface. The other important part which you should remember is that you should suppress finalization in your dispose method, because you have already cleaned up the resources and you don't want the two-stage expensive finalization to happen. Now, allow dispose to be called multiple times, even if the dispose has already been called, but do not allow other methods to be called after the dispose has been called. You should throw an object disposed exception from other methods. Call dispose on base classes and on all iDisposable members. If you're referencing other objects, you should be calling dispose on those members too. Now, keep the finalizer code simple to prevent blocking. Why? The reason is because if you are implementing complex functionality or thread-safe code, this might lead to hangs and unpredictable behavior. Provide thread-safe cleanup code only if your type is thread-safe. Now, this is very important because it will unnecessarily lead to redundant synchronizations which might not be even helpful. I think that's pretty much it about the dispose pattern. Let's take a look again at the code snippet. You have my class, which implements the iDisposable interface. Then you have a private bool variable. Then you have a public dispose method, which is a member of the iDisposable interface. And within that, you call the protected dispose method. And after that call, you suppress the finalization process. Now, in the finalizer, you call the protected dispose method by passing false as the Boolean value. And this is a protected dispose method which contains the actual cleanup code. That summarizes the dispose pattern.
Well, we thought it would be nice to give you a sense of some of the differences that applying this guidance can make in a real application. Now, what we've created here is not really a great real application, but it's just meant to give you an illustration of some of the things that we've been talking about. Now, in this guide, we have a whole chapter on COM interop, and I want to tell you a little bit about what we've done here. We've created a VB6 COM object, and like many VB6 objects, it has a very chatty interface, and it's meant to simulate credit card authorizations. So you set the credit card number, the expiration date, and so forth, and then you call this authorize method. Now, I have here opened, we've added some performance counters to our application, and I've opened Performance Monitor so you can see what's happening with it. And as you note here, when it's doing interop, we're getting about, looks like somewhere between 60 and 90 authorizations per second from this COM object, which isn't too bad. You know, that might be enough for your application. But if you were to consider moving this application to visualbasic.net instead of running it through COM interop, I want to show you what happens. Now, when I begin running the native version of this object, which was ported to VB.net, you notice an enormous difference. Now we're up into, you know, somewhere between 20 and 50,000 operations per second. So you can see that the COM interop boundary makes a big difference, and it's something that you should really consider if you have VB6 objects that need to be used, especially from server applications or ASP.NET. Not using COM interop makes an enormous difference. Now, let me show you one other thing that's going on here. You'll notice the performance counters I have up above here, and you can see that these are simply performance counters from .NET from the CLR memory. And if I'm running the native test, you'll notice that I was running this earlier, so I have some Gen 1 collections that have happened, but basically as I run this, you'll see there's a lot of Gen 0 collections going on. That number is increasing dramatically. But the Gen 1 collections are not. And that's because what's happening here is I have, in my credit card object, I've made use of the dispose pattern that Ashish just talked about. And my client application is allocating this authorization object, setting properties, calling the method, and then disposing it. And this is really a good practice because now we're cooperating with the garbage collector. But watch what happens when I uncheck this box. Now we're not disposing of the object, which means that the garbage collector has to run the finalizer. And as Ashish said, this causes the object to survive from Gen 0 into Gen 1. So the first collection goes on, the garbage collector notices that this object needs finalization. So now you can see that my Gen 1 collections has risen dramatically. And more importantly, this number that shows the percentage of time being spent in the garbage collector has risen dramatically as well. You can see that it's ranging between 7 and as much as 20%. So that's an enormous amount of time spent in the garbage collector simply because we didn't dispose of the objects. Now if I check that box and go back to disposing the objects, now you can see the percentage of time in the garbage collector is back down to 1 to 2%. So this is just a small example of how understanding something crucial about the way that the garbage collector in .NET works can make a big difference for your applications. So we'll hope that you'll take advantage of learning about these things and writing more optimized code.
Okay, so that was pretty amazing, really, to see the difference that you can make in your applications just from correctly applying
some strategies there. And you know, a lot of people have said to me, well, hey, I've got VB6 things. They work just fine. You know, why should I bother upgrading them to VB.NET? But as we saw in the demo, really upgrading your objects to .NET and not having to go through COM interop makes a big difference in performance, doesn't it?
Yeah, because you avoid a lot of chatty communication, you avoid hopping across the process boundaries, you avoid hopping across the interoperability boundaries. So it helps a lot. I mean, the chattiness is avoided completely, and intra-process, intra-domain, intra-boundary communications are always helpful.
Yeah, and the other key thing that was really amazing, and I think this is a big change for a lot of people, is now that we're moving into a managed world, you have to recognize there's a garbage collector, right? And I always like to say it's like having a garbage collector is great, but you need to know when to take out the trash, right? There's something you have to know how to work with it. And that finalized pattern made a big difference.
Yeah, a garbage collector is one of the most efficient tools which is part of .NET. I mean, like any good tool, it's like it has some sort of artificial intelligence built into it, and you have to provide useful coding hints to get the maximum out of the garbage collector, and that is what the dispose pattern does.
Yeah, so working with it is really crucial to get that right and get the best performance out of your applications. So this guidance looks great. I know that everybody's going to be asking, well, when can I get my hands on it? So when is this going to be finished?
Well, we are done this month, and the online version of the guidance will be available sometime in early May, and the print edition will be available a few weeks after that.
And so just to be clear, I mean, we're making this available. The online version is free, right? You don't have to pay anything.
No, it's absolutely free.
How great is that, right? So I can just go download, but now it is rather large, right? It's 900 pages or so.
Oh yeah, but I mean, you can jump to any section. It is like task-based section. You don't have to read it end to end. It is like a reference book.
Okay, so, but if anybody's thinking, hey, I'm just going to download that PDF and print it and save a couple bucks, not a good idea, right? Okay, so, yeah, but if you like a book, you can download the PDF if you like, but if you like a book, you can go buy it, and we make those available. So we really encourage everybody to get this, download it, start building applications that are going to be high performance and high scale. And really, this isn't about building the best or fastest apps in the world, but it's really about knowing your objectives, measuring to know if you're meeting them, and managing the risk of building your projects in relation to good performance and scalability principles. So thanks for joining us on this MSDN TV segment, and we'll see you in the future.
Thanks a lot.